So we were in section 19.1, and we had developed a method for solving quadratic equations, ax squared plus bx plus c equals 0. And that method was completing the square. All right? So that brings us to two methods, because back in 14, we learned how to solve quadratics by getting them equal to 0, factoring, and breaking down. All right? But is everything factorable? Nope. So that method, while probably being your favorite, doesn't always work. And then we have this method, which always works, but the way math is, the more generalized, the more useful, but also the more difficult. That's just how that works. So what was the process? Well, the first thing was to divide both sides by a to get that x squared with a coefficient of 1, to isolate the variable terms, which means exile the constant, throw it to the other side, to complete the square, which was a process we practiced last time, and then factor the result, use the square root property, and solve. All right, so let's do, I did one example last time, so we obviously have a lot more examples we kind of want to work through. Let's say that I give you x squared minus 4x plus 26 set equal to 0. Now, you're just going to have to press the I believe button for a few more minutes tonight. This is not factorable. So we're not going to waste our time trying to do it by chapter 14's factoring. We're going to do it by completing the square. All right? So what's my a? 1. So divide everything by 1. That's okay, right? What's the next step? We will isolate the variable terms and exile the constant. And now we're going to do that process of completing the square. So just to remind you how that works, what do we do to get the number that goes in the blank? We take the negative 4, we cut it in half, which is negative 2, and then we square it, which negative 2 squares up to 4. Right? But if I add 4 to the left, I have to add 4 to the right. You guys agree? Mm-hmm. So, it's always going to be, oops, not that, just kidding. We're going to factor, and we're going to get x minus 2 all squared, because we engineered that perfect square trinomial on the left. And negative 26 plus 4 is negative 22. So we come up with that number to complete the square, to make that perfect square trinomial so that it factors nicely. Because originally, x was in 2 different locations. Not like terms with each other, so we couldn't just squish them together. So how are we going to solve for x if it's in 2 different places? We don't. Instead, we complete the square so that our x is in one spot, nicely wrapped up with a square bow. Then what do we do? Something else we practiced last time. Yeah, we use the square root property. If x minus 2 squared is negative 22, then x minus 2 is the principal or negative square root of negative 22. So that's that plus or minus symbol, right? X minus 2 is plus or minus the square root of negative 22. All right, something else we saw last time. What do I have to do now? Yeah, pull the I out. I don't know which one of you had that violent impulse, but it was correct. When we have a negative under the square root, that is not real, and so we pull the I out, that imaginary unit, to take care of that. And what is my last step? If I want to get x by itself, add 2 to the right. It's not like terms, so x equals 2 plus or minus I square root of 22. So I have 2 solutions in my solution set. One of them is 2 minus I square root of 22. and one of them is 2 plus I square root of 22. Was that okay? You see how this is something we wouldn't have factored, not unless you happen to see factors of 2 plus or minus I square root of 22, which most people do not. Now, these are real or not real solutions? These are not real solutions because we have that imaginary unit I. But we do have two solutions in the complex world. All right? What if I give you 1/8 x squared plus x plus 5 halves set equal to 0. And we want to solve this by our method of completing the square. So who's playing the role of A now? 1/8. So again, first step, we got to divide both sides by whatever that A is. Get rid of it. Now in this case, dividing by 1/8 is the same thing as multiplying by 8. So let's do it. We get 1x squared plus 8x, you guys agree? Plus 20 set equal to 0, right? The 2 would reduce the 8 to a 4, and 4 times 5 is 20. Is everybody on board? So step 1, we got rid of A. Step 2, separate them out. So we have the variables, x squared plus 8x, and we exile a constant, so equals negative 20. What do I need to add to complete the square? Take 8, cut it in half, which is 4, square it. So I'm going to add 16. You guys agree? And if I add 16 on the left, add 16 on the right. So how does that perfect square trinomial now factor? Hint, I wrote it. Just have to read. X plus 4 quantity squared. Negative 20 plus 16, on the other hand, is negative 4. All right, now that I have x all in one spot, nicely wrapped up with that square bow, what do I do? Yeah. X plus 4 equals the principal or negative square root of negative 4. Remember that square root property. So x plus 4 equals plus or minus square root of negative 4. What can I do with that square root of negative 4? Pull the I out. And then the square root of 4 becomes 2. So we have x plus 4 equals plus or minus 2i. And if I'm solving for x, subtract the 4. It's not like terms with 2i, so that means x equals negative 4 plus or minus 2i. So again, two solutions in my solution set, negative 4 minus 2i, negative 4 plus 2i. Are these real? No, these are not real. These are imaginary. Right? Which, again, what I said last time, ironically, given the name, highly applied. Right? In electrical engineering, so all around us. All right, let's try another one. Let's say that I give you 5x squared minus 10x plus 2 set equal to 0. And I want you guys to kind of help guide me through this one a little more. So again, take for the moment that this is not something we would factor. Right? Then how would I have to solve this quadratic? You divide by 5. Step 1, get rid of a. And who's playing the role of a here? 5. So we divide by 5, even if it makes your dreaded arch nemesis the fraction. X squared minus 2x plus 2/5 equals 0. Then what do we do? Exile the constant. So you got x squared minus 2x equals negative 2/5. Right? Remember those forms we were doing last time where we had the x squared plus n times x, and we were doing the completing the square just on those forms? So what is it that I would do to complete the square on this one? What goes in this blank spot? Half of negative 2 is negative 1, which squares to plus 1. Right? A square is always going to be positive, except I squared. That's why we had I squared. But if I add 1 to the left, add 1 to the right. How does that perfect square trinomial on the left factor? Yep, so we write x minus 1 squared. It's always the number after you cut it in half, but before you squared it. Meanwhile, negative 2/5 plus 1 is 3/5. You guys have a calculator. You can math frac it. Nobody will ever know. But if we did it by hand, your common denominator would be 5. So negative 2/5 plus 5/5 is how I got 3/5. Everybody on board? All right, so now that x is nicely wrapped up, what can we do? Square root property. If x minus 1 squared equals 3/5, then x minus 1 equals plus or minus the square root of 3/5. You guys agree? Now what? Add 1. It's not like terms, or like radicals, I should say. So when I add 1, x equals 1 plus or minus the square root of 3/5. Two solutions, 1 minus square root of 3/5, 1 plus square root of 3/5. Are these solutions real?
Yes.
Yes. These are real. Now, are they rational? No, they're irrational, but they are real. There's no imaginary unit, so these are real solutions. Is that okay? Now, as far as the test is concerned, this is optional. However, we did practice rationalizing the denominator. So I could multiply the top and bottom by square root of 5 to get an alternative solution set of 1 minus square root of 15 over 5, 1 plus square root of 15 over 5. And those are acceptable answers as well. They've just had their denominators rationalized. Right. I am not demanding when it comes to rationalizing. You do have to simplify square roots. You do not have to rationalize. Except on last test where it said you had to rationalize. All right. What if I gave you 9x squared minus 30x plus 20 set equal to 0? Right. Again, just for a little bit longer, press the I believe button that this would not be something factorable. Okay. Then how would I go about solving this one?
Divide by 9.
Yeah, I got to get rid of a. A is played by 9, so I'll divide everything by 9. So that gives me x squared minus 10 over 3x plus 20 over 9 set equal to 0. Do not be scared of fractions. They are a part of life. So we got rid of a. That's usually the biggest mess that people make is they forget the very first step. Right? You got to get rid of a, which was the 9 in this case. Now what?
Subtract 20 over 9.
Yep. Exile the constant. So if we subtract the 20 over 9 over, we get x squared minus 10/3 x equals negative 20 over 9. And we fill that blank now, fill that space with that special number. So what do? We take negative 10/3 and we cut it in half. What's half of 10/3? 5/3? You guys agree? And what is that squared? As mentioned, 25/9. All right? Ye of little faith, remember, you do have your trusty sidekick. If I take negative 10/3, and I have it, H-A-L-V-E, is a good English word you won't see a lot of. There's your negative 5/3. Square that sucker. Math frack it again. There's your 25/9. The process is there. I don't care how you get there as long as you get there. But if I add 25/9 on the left, I have to add 25/9 to the right. And in this case, that actually happens to be fairly convenient. So how does that perfect square trinomial on the left factor? X minus 5/3 squared. It's always that way. It's always that number you got in the middle of that process. Equals, on the other side, that's actually already like denominator, right? So that's easy. 5/9. You guys agree?
You're saying negative 5/3 is always going to be that number?
The number when you divide it in half and before you squared. Yep.
Okay.
This is a very calculated process. We specifically engineer it to do what we want. Right? You tell the math what to do. Or you lose points on the test. All right, so now that we've done this process, this completing the square, we can use the square root property. So x minus 5/3 should equal plus or minus square root of 5/9. Square root of 9 simplifies to just 3. So we can write x minus 5/3 equals plus or minus square root of 5/3. And my last step, add the 5/3. So x equals 5/3 plus or minus square root of 5/3. They aren't like radicals, no matter how close they look, so you can't just squish them together. And I have two answers in my solution set. I have 5/3 minus square root of 5/3, and I have 5/3 plus square root of 5/3. Are these solutions real? Yes. These are real solutions, no imaginary unit. Are they rational? No, they're irrational, but they are real. Now, it seems like a lot at first, but the more you practice completing the square, the faster you can get. For example, it's very reasonable to ultimately be able to just do this whole thing in one step, to go from x minus 5/3 squared equals 5/9 to going to x equals 5/3 plus or minus square root of 5/3. It's not that big of a jump. Not that big of a jump when you really practice. Okay? But if you have to write it in all these different steps, totally fine. As long as we get there, baby steps work just as well as leaps. What if I gave you, say, 2x squared plus 9x plus 10 equals 0? What should I do?
Divide by 2.
You guys agree with her? How many guys say divide by 2? All right. So that means we get x squared plus what? 9/2x plus 5 set equal to 0. All right. What do I do now? We'll subtract the 5. So we have x squared plus 9/2 x equals negative 5. All right. Steps 1 and 2. Get rid of a and then exile the constant. So you isolate those variable terms. So what do I do?
Half of 9/2.
What is half of 9/2? 9 halves. If we cut that in half, we get 9 quarters. Does that make sense? You got your calculator, you can do it. Square gives me 36 over 16. So I'm adding 36 over 16 to the left. I add 36 over 16 to the right to keep the balance. How does that perfect square trinomial on the left factor?
X plus 9 squared.
You guys agree? I'm writing it, so that's a big red flag, but yes. X plus 9/4, the whole thing squared. What about on the other side? I see there's a little... Negative 11 over 4? No. It's not 36. What is 9 squared? 81. That's all right. So that doesn't change anything except on the other side. That's now actually just going to be 1/4. Or 1/16. So x plus 9/4 all squared is 1 over 16. You guys agree? All right.
Square root property.
Square root property is up next. So x plus 9/4 equals plus or minus square root of 1/16. Oh, but what is that? In this case, both 1 and 16 are perfect squares, right? So that means I get x plus 9/4 equals plus or minus 1/4. So something a little peculiar happened here. The radical went away entirely. So what is my next step? If I subtract 9/4 to the other side, x equals negative 9/4 plus or minus 1/4. This time, they are like terms and like radicals, because there's no radical. So guess what? I can actually do that plus or minus. For example, what is negative 9/4 plus 1/4? Negative 8/4, which is 2. And what is negative 9/4 minus 1/4? Negative 10/4, which is negative 5/2. Do you guys agree? So in my solution set, I have negative 2 and I have negative 5/2. You guys agree? Are you guys with me on this? Are these real? Yes. Are these rational? Yes. These are really nice answers, right? So guess what? We didn't have to do completing the square. To solve 2x squared plus 9x plus 10 equals 0, we could factor. I got 2x and x. I got 5 and 2. If my outer is positive 4 and my inner is positive 5, that gets me to 9. You guys agree? Then break it down. 2x plus 5 equals 0. X plus 2 equals 0. So we get x equals negative 5/2, or x equals negative 2. So, you guys like the factoring method. It's nicer, right?
So we can try first.
I'll have one better for you, right? Because how did I find out that I could factor this? Right at the end, which is not the useful point to discover that information, right? So I am holding out on you just a minute longer, but we will have a way to decide whether factoring is worth our time or not, all right? But notice I led you right into this trap. I didn't tell you this one didn't factor. You just assumed, all right? You know what that does, right? Mwahaha. All right, let's do one more, and then we're going to advance. Let's say we have x times 7x plus 1 set equal to 2. So this is a quadratic. What do I have to do with this one? Yeah, this is not correct factoring, so we need to multiply it all back out, undo it. So that means I get 7x squared plus x set equal to 2. You guys agree? Now, if this were factorable, we would bring the 2 over, get that standard form, right? That's always a good step, all right, to get into standard form. However, not factorable. So what do we have to do? Completing the square, and that starts with dividing everything by 7, getting rid of that 7. So that's going to give me x squared plus 1/7 x minus 2/7 equals 0. Now what? So I will add that 2/7 to the other side, exile the constant, get those variables isolated. So x squared plus 1/7 x equals 2/7. Now what?
Half of 1/7 squared.
What is half of 1/7? 1/14, and that's going to square up to 196? Did I get it?
Yeah.
Go me. So we're going to add 1 over 196. But if I add that to the left, I add it to the right as well. I ran out of room, so I'm going to go to the next one. So, on purpose, we made a perfect square trinomial on the left, and we know how it factors.
X squared plus 114.
X plus 1/14
Squared.
squared. So we got x plus 1/14 squared. What's it going to be on the other side? It's too late to do that.
Calculator, yeah.
That's under the Life's Too Short banner. So I get 57 over 196. You guys agree? Now what?
Square root both sides.
Square root property. So if x plus 1/14 squared equals 57 over 196, x plus 1 over 14 equals
Plus or minus.
plus or minus
The square root.
the square root of 57 over the square root of 196 was 14. You guys agree? My last step. Subtract the 1/14. So x equals negative 1/14 plus or minus square root of 57 over 14. I have two solutions. Negative 1/14 minus root 57 over 14. And negative 1/14 plus root 57 over 14. Are these real? These are real. Are they rational? No, they're not rational, they're irrational. So is this one we could have done by factoring? Not practically speaking. All right, this is one in which we would have had to complete the square. All right. So let us look at our next section, 19.2, called quadratic formula. All right, so let's do a little bit of development here. Let's say that I take ax squared plus bx plus c set equal to 0. That's a generic quadratic equation, right? And I'm going to solve this by completing the square. So how do we do this by completing the square? First thing we do, divide by a, literally this time. All right? So if I divide by a, I get x squared plus b over a times x plus c over a equals 0. All right, next step.
Subtract C.
Yeah, we're going to subtract the c over a. That's the constant, since x is the variable. So that means we have x squared plus b over a x is equal to negative c over a.
Half of B, X, half of that. 1/2 B over A.
So wouldn't that be 1b over 2a? How does it work when you hit a fraction with another fraction? Just multiply straight across. So 1 times b and 2 times a. Is that all right? And if I square that, I get
B squared over 2, or, 4A
b squared over 4a squared. So we add that to both sides. So b squared over 4a squared added to both sides. On the left, that means we've made a perfect square trinomial. That is going to be x plus
2B over 2A.
b over 2a all squared. And on the other side,
Negative C over A.
so that's the same thing as b squared over 4a squared minus c over a. Isn't that true? And how would I put those together? With a common denominator? What's the common denominator there? We're going in the other direction. Not a common factor, but an LCD. It's 4a squared. So if I put it all over 4a squared, because that's the LCD, then I don't have to do anything to b squared, but then it's going to be minus 4ac, because that one's missing a 4 and one of the a's. Does that make sense? Now what?
Square root.
Square root property. You got it. So this is going to be x plus b over 2a equals plus or minus one big happy square root of b squared minus 4ac. And then on the bottom, the square root of 4a squared is 2a. Some of you guys see where this is going.
Yeah, it's literally quadratic formula. That's what we're doing.
Last step is to subtract b over 2a. So x equals negative b over 2a plus or minus square root b squared minus 4ac all over 2a. And isn't that a common denominator? Then I could write it all over that common denominator of 2a. And here's the magic. It's a little fuzzy, so I'll rewrite it a little nicer. So for me, that was a test question in 9th grade on a test to do that. All right. So we can write it x equals negative b plus or minus square root b squared minus 4ac, and it's all over 2a. That's a common denominator, so that fraction bar goes all the way. All right. You guys heard of the quadratic formula before? You just assumed it was made up?
No.
It came from completing the square. So here's the good news. Completing the square always works. Since the quadratic formula comes from completing the square, it means the quadratic formula always works. Okay. Now, if you are not familiar with the formula, there is a song, right, which I will not sing for you because 2 ways I show I care for people. I don't sing at them and I don't cook for them. Right? But little Emily will sing it for you. So here we go. She's just singing the formula. It's Pop Goes the Weasel. And she's super excited about it. And some of you guys could do with some of that excitement. And I don't know where she was. She just ran off. So there you go. All right? Don't sing the song during the test, but you can think it in your head. All right? If you write the formula down every time you go to use it and maybe sing it in your head, you'll get this down in no time, I promise you. All right? So this is our quadratic formula. And you can still feel smarter than Emily because even though she can sing it, she doesn't know what it means yet. You're still smarter, if just nominally. All right. So let's see how this method sits alongside our other methods. So we're going to sum up here. Method 1, this came from chapter 14, was factoring. So how do we solve a quadratic by factoring? We put in standard form, ax squared plus bx plus c equals 0. We got the 0 on one side, right? Then what did we do? We factored that quadratic. Right? All those processes of factoring, GCF, followed by, if it's a trinomial, usually trial and error, but occasionally we had some special forms. Right? Once we factored, we broke it down, setting each factor to 0. This didn't work with any other number. It has to be 0. Right? And then we solved the resultant baby equations. Right? That was our method. And that was great. You guys like that method the best. And it is usually pretty easy to use when it's applicable. But not everything's factorable, right? Method 2, completing the square. First thing we do is get rid of that a. Right. Ax squared plus bx plus c equals 0. We'll divide everything by a. Right. Move the constant to the other side. Exile that constant because we need the constant that works for us, which is probably not the one that was there. So kick it out.
That's the part that's confusing.
Then we add that 1/2 n squared to both sides. That's that completing the square component. We add that specific number to both sides. Well, I'll just leave it as factor. Then square root and solve. And remember with that square root property, you pick up a plus or minus. Because what are the square roots of 25?
5
5 and negative 5. Both of them square to 25. So when you use that square root property, it's always plus or minus. All right, so this is method 2. A little more complicated than factoring, but the upside always works, no matter what. All right, so there's comfort in that. Now we have method 3, using the quadratic formula. First step, put in that standard form. Right? That standard form is always a good first way to start out. ax squared plus bx plus c equals 0. All right? Step 2. Clear fractions with the LCD. You can plug fractions into the quadratic formula if you insist. All right? This is not ideal. All right? So kill the fractions. It is an equation, therefore you can do that with the LCD. All right? Then we're going to plug into the formula, plug your a, b, and c into x equals negative b plus or minus square root b squared minus 4ac all over 2a. I actually had to try not to sing it. You're welcome. And then you're going to simplify completely. All right? Now, that often means breaking down the square root. All right? It also often means reducing by a common factor if there is one. All right? Common mistakes. So let's give this a try. Let's say that we have 9x squared minus 30x plus 20 set equal to 0. So this is one we actually already did completing the square on. All right? Nevertheless, let's see it with the quadratic formula. So, is it standard form? Yes. Do we have any fractions? No. What is your a? 9. What is your b? Negative 30. What is your c? 20. Notice that when there was a minus sign, we took it along with a, b, or c. But not variables. We're just looking at the coefficients. If you don't know the formula, write it out every time you go to use it. You'll get it quickly. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, even for quadratic formula veterans, my recommendation to you is to just plug in. Take one step just to plug in. Don't try to do any simplifying on the plug-in step. You'll make careless mistakes. Just plug in, then simplify. So x equals negative minus 30 plus or minus square root negative 30 squared minus 4 times 9 times 20 all over 2 times 9. All right. Now, I mean, if you really want to go fast, you can try it. I'm just saying, you're going to kick yourself for making stupid mistakes and losing points. So I took a step just for plugging in. All right, so minus negative 30 just means 30. Plus or minus, that's going to be 900 minus 720.
Doesn't your square root take away square?
Not with the minus there. Not with the second term. So we have to do the inside first. It's a good point to bring up. All right, so that means we wind up with x equals 30 plus or minus square root of 180 all over 18. You guys agree? $180 breaks down, if nothing else, 18 and 10, right? Which is 9 and 2 and 2 and 5? Where 9 is 3 and 3? If you guys thought you were escaping anything, you were wrong. Haunted until your dying math day. So what can I bring outside of that square root? I can bring out a 2 and a 3, so 6, and then left under the square root is just a 5. Is that okay? So 30 plus or minus 6 square root of 5 over 18. Can I factor? Is there a common factor here? There is a 6. So if I factor out 6, that's going to be 5 plus or minus square root of 5 all over 18. You guys agree? In which case 6 reduces 18 to 3. So x equals 5 plus or minus square root of 5 all over 3. Did you guys see how that worked? In my solution set, 5 minus square root of 5 over 3. 5 plus square root of 5 all over 3. Are they real? Yes. Are they rational? No, right? So this was not one we would do with factoring. Again, it was only at the end that we found this out, right? But it's not. Now we did this one with completing the square, right? Are those the same answers we got when we did completing the square? So here's where we solved this one with completing the square. In this case, I mean, like I said, if you completing the square enough times, it actually becomes the fastest method. I know you guys think the formula is a warm blankie that you pull over you at night, and that's okay, all right? But completing the square actually winds up being the fastest. Now, are those the same answers? Yeah, what's the only difference?
Just rationalizing the denominator.
Actually, as far as you doing completing the square, I don't mind if you don't rationalize the denominator. But what happened here was put it over the common denominator or break up the previous one, and you would get the same answers.
Oh.
I'm fine either way. Again, it's just kind of the different methods take you to slightly different looking answers, but they're right one step apart. Let's try another one. Again, just so we build our faith, 1/8 x squared plus x plus 5 halves set equal to 0. So once again, this is one we actually solved already using completing the square. Now we're going to solve it using the quadratic formula. So first off, are we in standard form? Yes. ax squared plus bx plus c equals 0. What is a? 1/8. What is b? 1. What is c? But do we want to plug in fractions into the quadratic formula?
No.
Mathematically, it's fine. However, you'll get lost in fraction Hades. Right? And there is no recovering your soul from that. So what can we do instead? Yeah, LCD here is 8. So let's hit everything with an 8, giving me an x squared plus 8x plus 4 times 5, which is 20. Set equal to 0, right? Because wouldn't the 2 reduce the 8 to a 4? And 4 times 5 is 20. Now who's playing the role of A? 1. B? 8. And C? 20. So again, write the formula down if you need to. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And then we'll just take a step to plug in. So this means I have minus 8 plus or minus square root 8 squared minus 4 times 1 times 20 all over 2 times 1. You guys with me on that? Everybody on board? All right, so x equals negative 8 plus or minus. That would be square root of 64. Gosh, I can't get that to save my life. 64 minus, and that would be 80 all over 2. You guys agree? So x equals negative 8 plus or minus square root 64 minus 80, negative 16 all over 2. So what do you see here? Got to pull the I out, right? So x equals negative 8 plus or minus I square root of 16 over 2. So now that I've pulled the I out, what do you see? Yeah, square root of 16 is 4. So x equals negative 8 plus or minus 4i all over 2.
The 8 and the 2. Well, the 2 reduces the 8.
The 2 doesn't just reduce the 8.
The 4.
Yeah, remember, if you cancel, what do you have to do? Factor. So what can I do here? Pull out a 4, which would leave you with negative 2 plus or minus I all over 2. So once we factor, can we reduce? This time there's a 2 left in the numerator. You guys agree? So if I multiply back through, that would be a negative 4 plus or minus 2i. Now, some of you guys could reduce down the 2 perfectly fine. But a common mistake there is to reduce it with the 8 and forget about the second term. That 2 was a common denominator, which means if it reduces, it has to reduce everywhere. All right, so factoring is a way to ensure you don't make that mistake. So we get 2 solutions in our solution set. Negative 4 minus 2i, negative 4 plus 2i. Again, same thing we got when we did completing the square. Yes. Same thing we got when we did completing the square. Are my answers real?
No.
No, these are not real. All right. They're all complex, but not all are real. And then not all real are rational. So it's a bubble within a bubble within a bubble. Let's try one more. Again, that we've already done. If I give you x times 7x plus 1 set equal to 2, how could I solve this? Yeah, this is bad factoring because it's not equal to 0. So that means 7x squared plus x equals 2. Then what would I do? Subtract the 2 over, because our goal here is to get it in that standard form, ax squared plus bx plus c equals 0. So I get 7x squared plus x minus 2 set equal to 0.
Divide by 7.
Well, let's do this with the formula. We already did it with completing the square. So if I'm using the quadratic formula, a is 7, b is 1, c is negative 2. Yep. Sing it if you have to. So if we plug in, x would be negative 1 plus or minus square root of 1 squared minus 4 times 7 times negative 2 over 2 times 7. You guys agree? So x equals negative 1 plus or minus square root, that's 1, and then that's going to be plus 56 all over 14. Minus a negative makes it a plus on the inside. So what do we have to do? Add, right? So x equals -1 plus or minus square root of 57 over 14. Does the square root of 57 break down? Not in this case. So I have my two answers. -1 minus square root of 57 over 14. -1 plus square root of 57 all over 14. Was that the same thing we got when we did completing the square? Yeah, we had the common denominator broken up when we solved with completing the square. And we have the common denominator put together when we do the quadratic formula, but it's the same thing. All right, on the test, I will tell you, solve this by completing the square. In which case, what do you have to do? Solve by completing the square. And then I will say, solve using the quadratic formula. In which case, what do you do? Solve using the quadratic formula. There's no problem with using the other method to check, but at least you have to do it using the method asked. All right, nobody's shocked. All right? So that means you will have to know how to do all three methods. Right? We already tested on method 1 because that was chapter 14, but it's still around. Right? It's still around. In fact, it's relevant because in the grand scheme of things, method 1, using factoring, was kind of the nicest one, right? Not just because we learned it 5 chapters ago, but because it's generally having nice numbers as answers. It's generally rational and easy to factor. So the question is, how do we know if we can factor or not? Right? The end is not the ideal place to find that out. Well, I'm glad you asked. Let me answer. So we define the discriminant, right, to be b squared minus 4ac. Does that look familiar? What part of the quadratic formula is it? It's the part that's under the square root. Right, the part that's under the radical. So let's look at how this discriminant plays a role in what's going on here. So, if we use D to represent the discriminant, D equals b squared minus 4ac. All right? Then there are 3 things that can happen. What happens if your discriminant is positive? So that b squared minus 4ac gives you a positive number. Well, think about it. We have in the formula plus or minus the square root of that discriminant, right? So if it's a positive number, you wind up getting plus or minus 2 different the square roots, right? So you will get 2 unequal real solutions. They will be real. Right? They will be real. Now, within that, we have something to talk about, but let's skip ahead. What if D is less than 0? So that b squared minus 4ac comes up negative. So this would be a negative number under a square root in the formula, right? What happens when you have a negative number under a square root? You pull the I out. You pull the I out, which means you're going to have 2 non-real or imaginary solutions. Now that we've talked about the complex number system, we can do more than just real numbers. We can do imaginary numbers as well. So if D is greater than 0, you get 2 distinct real solutions. If D is less than 0, you get 2 distinct imaginary solutions. Right? And if we really delved into it, those are always going to be complex conjugates. That's the way it's always going to come out. The last case, what if your discriminant actually comes out 0 perfectly? So b squared minus 4ac actually comes out 0. then you get one repeated solution. All right? Now what that repeated means, you'll talk about in college algebra. Right? But you won't get two distinct answers. You're just going to get the same answer twice. All right? Which would mean that's a perfect square, right? That's what happens when you get x plus 4 squared, for example. So here's the real part. I mean, that's all great and good, but the juicy part is in that case 1, when your discriminant is a positive number. If that discriminant is a perfect square, then your solutions will be rational numbers. And that means they're nice. And if they're nice, that means we could solve by factoring. All right? So this is a way for us to determine if we can solve by factoring before we solve and find out, oh. Right? Use the discriminant. It's a very easy plug right at the beginning. B squared minus 4ac, right into your trusty sidekick. If it comes out a perfect square, by definition perfect squares are positive, then what do you know? Solve it by factoring. Right? If not, then you have to either complete the square or use the quadratic formula. Right? Now, even if it is factorable, you guys have seen some before where you didn't like factoring it because they were big numbers and you guys are just chicken. Right? Then completing the square or the quadratic formula would still always work. So if you just don't feel like factoring that day and the instructions didn't specify you had to factor, then you could do completing the square or the quadratic formula. All right, so let's do some practice using this discriminant. So let's say that I start us out with x squared minus 2 is equal to 7/2 x. So I'm not asking you to solve this right now. I'm just asking you to use the discriminant to kind of see ahead of time where this would go. So what's the first thing that's wrong here? It's non-standard form. So that means subtract that 7 over 2x to the other side, right? Descending order matters. So how should I write it? X squared minus 7/2 x minus 2 equals 0. You guys agree? What do you want to do next? We could jump right in. Who's playing the role of A? 1. Who's playing the role of B? Negative 7/2. Who's playing the role of C? That's fine. We're only plugging into the discriminant, b squared minus 4ac, which would be negative 7/2 squared minus 4 times 1 times negative 2. Now you can just plug and chug into your calculator, right? This isn't overly complicated. So it's actually going to wind up being positive 81/4. You guys agree? Is that a perfect square? Yes. So guess what that means? Yep. There are two real solutions. We can get by factoring. All right, now this is the way you guys took it. I mean, you can live with fractions if you want to, but you don't have to. Alternatively, what could I have done? Multiply everything by 2, so 2x squared minus 7x minus 4 equals 0. You guys agree? Using your LCD? In which case, A is 2, B is negative 7, and C is negative 4. Make your lives a little easier. So the discriminant, which is b squared minus 4ac, would be negative 7 squared minus 4 times 2 times negative 4. This winds up being 81, which is still a perfect square. So it didn't change the result. What is the result? There are two real solutions we can get by factoring. So why don't we? So in order to solve this using factoring, we take that x squared minus 2 equals 7/2 x. We would bring it over to get 0. We would use the LCD to kill the fractions. This is all standard procedure. And we'd have 2x squared minus 7x minus 4 equals 0. So what do you got?
2 plus 1 x minus
2x and x, 1 and 4. We know that's the only possibility because we don't want to create a GCF where there wasn't one. So it can't be 2 and 2, and it can't be 4 and 1, so it's got to be 1 and 4. If my outside is negative 8x and my inside is x, there we go, right? In which case we get x equals negative 1/2 and x equals 4 as our potential, or as our solutions. Those are our solutions. Are these real? Are these rational? Yeah, as promised by the discriminant. All right. What if I give you, say, five x squared plus 7 equals 0? So this one is a quadratic. It's in standard form, right? So let's check the discriminant. Who's playing the role of A? 5. Who's playing the role of B? 0. Who's playing the role of C? 7. Why? Yeah, isn't there a missing term there? How many x's do I have? Well, that's a personal question. 0x. 0x. In which case, if I'm doing the discriminant, D equals b squared minus 4ac. That would be 0 squared minus 4 times 5 times 7. That would wind up being negative 140. You guys agree? Which is negative. So what does that mean? There are two imaginary solutions. So this means I can't do this by factoring, because by definition, perfect squares have to be positive. But this one's not too bad. Because there is no x term, then our x is not in two different places, it's just in one. So what we did last class, how could we solve this? Subtract 7. Divide by 5. And then what's up? Square root property. If x squared equals negative 7/5, then x is plus or minus square root of negative 7/5. In which case you would pull the I out. So x equals plus or minus I square root of 7/5. So my two solutions, negative I square root of 7/5, positive I square root of 7/5. Should we choose to rationalize the denominator, I would multiply the top and bottom by square root of 5. Then x would be plus or minus I square root of 35 over 5. Which is fine. I don't require that you rationalize the denominator. All right, again, the discriminant doesn't solve the quadratic equations. It just gives you some foresight into how you could go about solving it. All right? What if we attempt 2x times 3 minus 2x, is that equal to negative 1? Multiply it out? Yeah, this is bad factoring. So you'd multiply it out. That would give me 6x minus 4x squared equals negative 1. You guys agree? Add 1 and put it in descending order. So tell me what to write. Negative 4x squared
Minus 6x. Or plus 6x.
plus 6x
Plus 1.
plus 1
Equals 0.
equals 0. That's what you guys told me to do. Now, nobody says I had to bring it over to the left-hand side. I could have brought it over to the right-hand side if I were so inclined. I just did what you said. This is your fault. All right, so if we are going to check our discriminant, and again, this is something you could quickly punch into the calculator. What is A? Negative 4. B? 6. C? 1. So for the discriminant, b squared minus 4ac, we would have 6 squared minus 4 times negative 4 times 1. So that would be 36 plus 16. What is that, 52? I'm mathing solo, that's always dangerous. What does this mean? There are two real solutions. They are real. But are they going to be real pretty? No. So we cannot get by factoring. 52 is not a perfect square. So although we're going to get two real solutions, they're going to be irrational, and therefore we don't want to approach this with factoring. So how do you want to solve this one? You're going to say the quadratic formula. What do you need to see more of? Completing the square, and you know it's true. So let's solve this by completing the square, in which case, what do I need to do? Divide by negative 4. Get rid of a. So divide by negative 4. So we get x squared minus 6 over 4 reduces to 3 halves x minus 1/4 equals 0. You guys agree? All right, next up. Add that 1/4 over to the other side. Exile the constant. Get your variables isolated, exile the constant. X squared minus 3 halves x is equal to 1/4. So what do I do? What is half of 3 halves? 3/4. What is that squared? 9/16, right? Add 9/16 to both sides. How does that factor?
X plus 3 plus squared.
So close.
Oh.
It's x minus 3/4 squared. You always know the sign because it comes from the original sign there. Equals 13/16. You guys agree? So how horrible is it if I tell you that that means x is 3/4 plus or minus square root of 13 over 4? Ta-da! If you take 5 steps to get there, that's okay, as long as they're all good steps. Right? But if you practice enough, that's how fast you can get with it. You can actually do that probably faster than you can factor sometimes. Right? So just to do it out, x minus 3/4 would be plus or minus square root of 13 over 16. So x minus 3/4 would be plus or minus square root of 13 over just 4. And if I add the 3/4 over, I get to my answer. You guys with me on that? Right? Did I show off too much? But you guys can do that too. You guys can be that person who shows off your completing the square skills. All right. So let's have a boss fight. All right. Let's say that I give you x minus 1 over x minus 2 plus x over x minus 3 set equal to 1 over x squared minus 5x plus 6. You guys recognize one of these? So we have a rational equation here, but this time there's no guarantee that those answers are going to be pretty. Slash, they're not. So how can we solve this? We need the LCD, and in order to get the LCD, we need to see what we got, right? So if I factor out that last trinomial, that's x and x and minus 2 minus 3. 6 and 1 would work if it were minus 6 and plus 1, but then it wouldn't check out with your lasts. So be careful, right? So what do I need in my LCD? X minus 2, x minus 3. This means, by the way, x cannot be 2 or 3. That would make division by 0, and we remember that that's bad. Right? If you take nothing else away from math, you don't divide by 0. All right, so what do I do? Multiply everything by the LCD. So for the first term, x minus 2 cancels. So you get x minus 3 times the x minus 1 that's already there. So x minus 1, x minus 3. Plus, for the second term, x minus 3 cancels. So you have x minus 2 times the x that's already there. So x times x minus 2. Set equal to 1. Both of them cancel on the right, so you just get the 1. Everybody on board? Now what? Multiply it all out. So that means foiling the first one, x squared minus 4x plus 3, and distributing for the second one, so x squared minus 2x, is that equal to 1? You guys champion multipliers at this point? I'm hoping for you guys. Combine like terms, that's going to give me 2x squared minus 6x plus 3 equals 1. And now our moment of truth.
Oh, good. We can do that deep.
Yep. I'll subtract 1 over and get 2x squared minus 6x plus 2 equals 0. So this is something we can pop in really quickly. So if we pull up our trusty sidekick, how would I plug in the discriminant? Negative 6 squared minus 4 times, what was your A? 2. Times, what was your C? 2. And we get 20. So what does that mean? Factoring or no factoring?
Factoring.
20 is not a perfect square. What are perfect squares? 16, 25, but not 20. Yep. 0 while we're at it. So we cannot do this by factoring. So who's up?
Completing the square.
Completing the square or quadratic formula. Let's do some completing the square. You guys need to see it, right?
You can do the LCD right there.
So what do we have to do? Divide by 2. So dividing everything by 2. You didn't even make your dread enemy the fraction. All right. So that's not the worst thing you've ever had to do. X squared minus 3x plus 1 equals 0. Next up. Exile the constant, right? Whatever that number is, throw it to the other side because it's probably not the one we want. Then what do we do?
Got 3.
What's half of 3? 3 halves, right? Which squares to 9 fourths. You guys agree? So we get x minus 3 halves squared set equal to 5/4. Everybody on board? So from here, x would be 3/2 plus or minus root 5 over 2. Ta-da! All right, all right, all right. Square root property, x minus 3/2 equals what? You tell me. Busted. Plus or minus.
That's given.
It's not. Trust me, I grade them. It's not a given. Plus or minus square root of 5 over 4. So that means x minus 3/2 equals plus or minus square root of 5 over 2. And if I add 3/2 over, there it is in all its glory. Your solution set, which has how many solutions? 2 of them. 3/2 minus root 5 over 2. 3/2 plus root 5 over 2. As promised, these were 2 real solutions, but they were not rational. They were irrational. Therefore, we didn't get them by factoring. Is that okay? Whew. All right. Now, just to finish up, right, it's not a boss fight, but everything in math is a two-way street. So what if I give you solutions to a quadratic and ask you to come up with the equation? Let's give it a try. Let's say I start with solutions -2 and 3. These are nice solutions. If I put them together, this would have been x equals -2, x equals 3, so x plus 2 equals 0, x minus 3 equals 0. You guys agree? Backing up further, that would be x plus 2 times x minus 3 equals 0. You guys agree? In which case we get x squared minus x minus 6 equals 0. So this is a quadratic equation with those solutions. It's not the only one. Right? I could just multiply everything by 2 and there's a different one with the same solution. So there's infinitely many, but this is a version. Do you guys see how I did that? Working that process backwards is a nice learning experience. So what if I gave you -3/5 and 1/4? In the grand scheme of things, are these nice answers?
No.
Yeah, they're rational. You know there's worse out there. So what would this be?
X plus 3 this equals 0.
Yeah.
X minus a quarter equals 0.
So if each of those are my x's, x minus 3/5 equals 0, x minus a quarter equals 0. Now, do you like fractions? Multiply the one on the right by 5. Multiply the one on the left or on the right by 4. And we get 5x plus 3 times 4x minus 1. Is that equal to 0? So I get 20x squared. I get 12x minus 5x, so 7x minus 3 equals 0. How do you guys feel about that? Yeah? Okay. Let's try something a little tougher. What if we had, in my solution set, -7i, positive 7i? Yeah, now I'm writing it out for posterity's sake, but as you get more comfortable, you can go quicker. So each of those is an x, so x plus 7i equals 0, x minus 7i equals 0. You guys agree? So x plus 7i, x minus 7i equals 0. What does this give me? Isn't that a difference of squares? So that would be x squared minus 49i squared set equal to 0. You guys remember your difference of squares? But from last class, I squared is -1. So x squared plus 49 equals 0 is our equation. Is an equation with those solutions, right? Which is all we were asked to find. All right, let's try one more. What if I give you 3 minus square root of 2, 3 plus square root of 2 as my solutions? So those are x's. So I would now need to move both terms, right? So x minus 3 plus square root of 2 equals 0. X minus 3 minus square root of 2 equals 0. You guys on board? That means their product, x minus 3 plus square root of 2, x minus 3 minus square root of 2 should equal 0. Now, multiplying this out, you could do the box, or we might notice if I group the x minus 3's together, this is a difference of squares. So I actually get x minus 3 squared minus 2 set equal to 0. You guys agree? If I multiply that out, that's x squared minus 6x plus 9 minus 2 equals 0. So x squared minus 6x plus 7 equals 0 is a quadratic equation whose solutions would be 3 plus or minus square root of 2. Is that okay? Now you're not going to be doing this much. It's just everything in math is a two-way street. Learning to walk backwards helps reinforce walking forward, but walking forward is more important. All right, let's make sure we don't fall on our faces.
So 2 times 2, 4 squared minus 2.
Square root of 2 squared is just 2.